Let's talk about strong acids and strong bases. The ionization. Actually, based on the ionization, the acids or bases are classified as either strong or weak. In strong acids and strong bases, the ionization is complete. It completely deionized. The strong acids and strong bases are completely ionized, like completely ionized into its the conjugate base and the conjugate acid. Right. So as an example, if this is the acid, if this is the strong acid, then we draw only this type of arrow because it is not in equilibrium. It completely goes all the way to its products, H plus and A minus. Right. So that is the difference between the strong acids, strong bases and weak acids and weak bases. Therefore, it's very easy to calculate the concentration of hydronium ions in the or H plus ions in strong acids because it is always equal to the starting concentration of the strong acid. The ionization in strong acid is complete. Therefore, the hydronium ion concentration of a solution of a strong acid is equal to the starting concentration of the strong acid. Here you will see the list of strong acids. They are complete go all the way to their products and there is no equilibrium. And if you check the ionization of um, sulfuric acid, there are two hydrogens, but the first ionization is the only the complete ionization in only sulfuric acid. Here is a practice problem. Calculate the pH of a solution at 25 degrees of Celsius where the concentration of HI, concentration of nitric acid, and concentration of perchloric acid are given. Before we move to the calculation part, we should decide whether these acids are strong acids or weak acids. Yes, HI, HNO3, and HClO4. They are all strong acid. Therefore, the concentration of the hydronium ion is equal to the starting concentration or the initial concentration of its acid. So we'll just the concentration of the H3O plus equals to their initial concentration of the acids, and the pH is actually the negative log of H3O plus concentration. So you plug those values instead of H3O plus and you will calculate the pH value for the solutions of these three strong acids. Next, now we are given the pH values of three different solutions of the hydrochloric acid. Yes, hydrochloric acid is a strong acid. So the H3O plus concentration equals to the initial concentration. Using these pH values, we calculate the H3O plus concentrations. Right, we got those, the concentrations, and then they are actually the similar, they are actually equal to the initial concentration of the HCl. Yeah, this is the concentration of HCl. Right. As an example, if this was the H2SO4, then what is the ionization? Yes. As an example, okay. Um, e, uh, yes, in a later on, we're going to calculate we'll look at the diprotic acid. Until then, if it is a strong diprotic acid, then we'll get 2H pluses. So then what is the initial concentration of the acid? Yes, the initial concentration of the acid would be the half of the concentration of the H plus ions, because it is depend on the stoichiometry of that balanced chemical reaction. In HCl, we didn't need to worry about that because HCl is a monoprotic acid, so it releases only one H plus. So this is 1 to 1. So it exactly equals to the initial concentration of the acid. Strong bases. Yes, strong bases again, also they ionizes, they ionize completely. If I can draw a strong base like this, again one arrow, so we'll get two ions, hydroxide ion and the metal ion. So, and the list of the strong bases are very short, is very short. So it's better to remember the list of the strong acids and the strong bases. That would be helpful in calculating the or answering the questions in your test. So again, with the strong bases, the reaction goes to completion. Therefore, pH of strong base is relatively easy to calculate because the OH minus hydroxide concentration equals to the initial concentration of the base, strong base. Here is an example. Calculate the pOH of following aqueous solutions. Now, okay, look at the lithium hydroxide. Yes, first we need to determine whether they are strong bases or weak bases. Yes, they are all strong bases. Then we need this reaction stoichiometry to determine the hydroxide concentration, right? So in lithium hydroxide, yes, lithium hydroxide completely ionized to lithium plus ions and hydroxide ions. So it is 1 to 1, right? The stoichiometry equals to 1 to 1. Therefore, hydroxide ion concentration equals to the lithium hydroxide concentration. And in the barium hydroxide, as you see in the equation, it produces two hydroxide ions by ionizing 1 mole of barium hydroxide. Therefore, the concentration of the hydroxide ions should be multiplied by 2. The concentration of barium hydroxide should be multiplied by 2 to get the hydroxide concentration in barium hydroxide solution. And this is the hydroxide concentration. In KOH, again, it is just like the lithium hydroxide. It is 1 to 1. So the hydroxide ion concentration equals to the initial concentration of the KOH. Now we plug those values here and we calculate the pOH values because we are asked to find the pOH. Another problem, an aqueous solution of a strong base has pH 8.15 at 25 degrees of Celsius. Calculate the original concentration of base in the solution. If the base is sodium hydroxide and if the base is barium hydroxide. So pH, we are given the pH, but these are bases, so we need the pOH. How do we calculate the pOH? Yes, if we look at this equation, pH plus pOH equals 14. and then we can get the POH value. Using the POH value, we can calculate the OH minus concentration. OH minus concentration. The hydroxide ion concentration will be helpful in determining the concentration of the base itself. Right. So we calculate the POH first. Right. Now, sodium hydroxide. Now we need to think about the reaction stoichiometry. Yes, sodium hydroxide by dissociation of 1 mole of sodium hydroxide produces 1 mole of hydroxide. Yes, it's 1 to 1. Therefore, the concentration of the base is equal to the concentration of the hydroxide ion. In barium hydroxide, we already talked about the ionization of barium hydroxide in the previous slide. So it is 2OH minus. So therefore, the concentration of the base is only 1/2 of the concentration of hydroxide ions. If the so we use the POH from there to calculate the OH minus concentration, and sodium hydroxide concentration is equal to the hydroxide concentration. But what is the barium hydroxide concentration? Yes, barium hydroxide concentration will be the half of the concentration of the hydroxide ions. So that would be the 7.0 times 10 to the negative 7 molar.